Hi, my name is Jocelyn Disla, and I will be presenting this fraud prediction analysis project. Managing and monitoring fraud along with other potential crime is very critical in any business operation to maximize efficiency and the business's potential. Fraudulent activity is unavoidable, especially with the significant amount of traffic that consumers create for an attractive product. By creating a model that allows an accurate prediction of potential scams, we can get an upper hand on these giant losses that come from out of the blue. This problem can cause many issues and even loss of profit if not supervised and kept under control. Fraud is a Pandora's box of issues that businesses struggle with because finding the course and reasoning behind the fraudulent transactions can be very challenging. These sources can range from emails, hacked accounts, lying clients, and even account protection issues that can cause a loss of consumers in the long run. A system that can detect these transactions as soon as they arise will be a game changer for institutions all around. The dataset from data.world is called Synthetic Fraud Detection Dataset, containing over 10,000 rows and 17 columns to describe potential frauds, such as the time the transaction took place and other important details pertaining to the transaction. I chose this dataset to provide a structured start to this model so that it may be applied to future collections of data. The rows containing non-values were then dropped from the dataset rather than being replaced by the average, since it wouldn't really make sense in this prediction analysis. Unnecessary and unnamed features were also removed. The data had dates formatted in a way that the machine could not correctly analyze. Due to this, I converted the values into a date-time format. This allowed the month to be extracted and used to display any patterns throughout the year. This dataset also provided the amount of money within the original source account that the transaction was pulling from and the destination account, which is where the transaction was ended in. The difference in these accounts were accounted for so that the remaining features could be disregarded. Lastly, categorical codes were used in place of categorical data to assign values that the machine would be able to recognize. A supervised learning k-nearest neighbor algorithm for classification was applied to complete a prediction task with a categorical target variable being fraud. Classification models learn how to classify any new observation. This assigned class can either be right or wrong, not in between. For example, in this dataset, the transactions are either fraud or true. The prepped data was then split into a training set, which was 75% of the data, and a test set being the remaining 25% of the data. This was done to avoid overfitting the data with one large set. The data was fit using a k-neighbors classifier. Feature importance is a step in building a machine learning model that involves calculating the score of all input features in a model to establish the importance of each feature in this decision-making process. The higher the score of the feature, the larger effect it has on the model to predict a certain variable. This model resulted in an accuracy score of 0.994. This accuracy is a bit high, too perfect in my opinion, but this can be explained by the dataset being synthetic. The RMSE score of the training set was 0.079, while the test set was not far along, being 0.077. This score is the square root of the mean squared error. These scores are not impressive regarding the model's ability to predict correctly. A plot was created to display both the testing and training set accuracy compared to the different k-values. This plot is displayed on the left side of the screen. The bigger the k-value, the higher the bias and the lower the variance. Around 4 would be the most optimal. Feature importance was plotted using a random forest classifier to identify the features with the most impact on the transaction's fraudulence. This plot is presented on the right of the screen displayed by the feature's index number. The original balance, being the top most important feature, signifies the change from before the transaction was made to its altered state. This feature falls closely with the amount of the transaction, which is second in the list. These two features are very similar since they describe similar aspects of the transaction. The destination balance difference is third on the list and signifies the end location, which is also worth digging into. Unusual login came up as fourth on this list. It is basically the alarm that goes off from an unexpected or abnormal attempt at accessing an account. These are all key signs to keep an eye out for criminal behavior. This model performed well with a high accuracy score as it is using a synthetic data set. The value of K is crucial, and determining this value can help with preventing overfitting or even underfitting the data, which was discovered to be 4 in this model. According to the chart on the screen, it is evident that the fraudulent transactions are not the smallest amounts of money, but also can range from average to very high amounts of money. Since the original account amount was top in the feature importance, this correlation chart is demonstrating the relationship between the original amount and fraudulent transactions. Overall, transactions with an amount that is irregularly large is more likely to be fraud. It seems that most scammers will stay under the radar by creating transactions that seem normal from accounts that carry larger funds so that it can disappear without raising an eyebrow. In the article Fraudulent Transactions 101, the author explains the numerous amounts of transactions that can occur with or without the account owner's knowledge. Moving forward with this analysis, implementing another data set to this model would help discover its newfound accuracy coming from a present-day institution. I would also recommend many companies to inform their clients on how to prevent hackers or scammers from accessing their accounts from either fake ads or dangerous websites. These precautions can save companies an abundant amount of income stemming from the future. Refining the features and their displayed information would also be beneficial considering the top 2 important features were very similar and even almost exactly alike. Some ethical points to consider would be to keep the confidentiality of consumers who are being investigated and also advising them of the investigation going on. There is no potential harm that may arise from this project. However, moving forward, the companies using this system should keep in mind their ethical responsibilities when it comes to their consumers. Challenges that may arise with this project would be deciding whether to add more algorithms to strengthen the claims of the system and implementing a natural data set. Here are my references so you can access the information presented for a better understanding. Thank you for listening in and watching this presentation.